And I think some questions, just how do you set it up, right? Because we were like, there is some communication questions here. Um, and okay, so let's see. So this is 8.2, or sorry, 6.2 homework. Take up. Watch out, I'm recording. Okay, I got 1C as a request. I got 3, 5, 6, 7, 10, 11. Will I get to all of them? I don't think so, but or I'll touch each of them, okay? Maybe at least how to get started. And again, I am recording this, so if you were really lost with the homework and you want to rewatch me explaining the homework, cool. I'm going to make that available. All right. So starting off with question 1C, which is a nice review of yesterday's lesson. Okay, so in this one, it's a bit tricky because the triangles are not lined up nicely. So I'm really glad this question is coming up, because it's like one of the challenges is, well, which ones go together? And I see that these two angles have a dot. That means they are congruent. I see W and C have one arc. That means they are congruent, i.e., identical. And then B has a double arc, as does X. So that means those two are congruent. Okay. And we're asked to find the unknown sides. Now, we can say, now let me show you, because some of you just found the answer. I want to show you how I want this to look on a test, in your work. So, first of all, we have to say if they are, or since, I like to say since more, since these two triangles are similar. Triangle WXY is similar to. Now, if you had trouble matching up, okay? So the first one is W. What matches with W? Well, I'm looking for a single arc. That's going to be C. What matches with X? It's the double arc. So it's going to be B. And then what matches with Y? It's going to be A. So I make sure I write them in the correct order. So my first statement is, hey, since I've got similar triangles, I can now do the following work. So now I look at which information do I have. I know this is 9. Actually, I'm going to make it. This is 9 centimeters. Why am I making it orange? Because it's side C. Okay. I also know, I don't know side W. I know that X is 5 centimeters. I don't know B. A is 6. Y is 4. So just by looking at the colors, you can see, oh, Y and A, I have information for both of them. That's the pair I'm going to use. You need to have one pair that is complete, i.e., you have the measurements for both triangles. So I'm going to start on, let's find side B. Find B. So I'm going to set up my two fractions. Doesn't matter which one's up top, okay? As long as it's always the same triangle. And I'm using the orange pair, right? No, I'm using the purple pair because that's what I have information for. So in this triangle, I'm looking at these two. So I've got 6. Now, the bottom one is this triangle XYZ. So what correlates to 6? Well, it's going to be the one opposite from the angle that has a dot. So that's going to be this one. How do I know that? Well, I also know that A is the last letter, so it has to be Y. And what is the length of Y? Oh yeah, it's across from the angle. It's going to be 4. Now, for the red pair, if side B corresponds to B, How do I know which angle on the other triangle corresponds to B? Well, it's the middle letter. So it's going to be the X. So across from the X, I've got 5. And do you see how this ends up being color coordinated? If you're having trouble, use highlighters to show which angles are corresponding. Okay? So the red ones are corresponding, the purple and the orange. Okay? And now I need to solve for B. I'll use my trusted T method. 5 times 6 divided by 4. Okay, that's 30 over 4. We know that's 7.5. I think we're in centimeters. Okay, now I need to find W. Same thing. Okay, now one of my fractions is going to be the orange fraction. I'll put the W at the bottom. Okay, which side corresponds to W? It's going to be side C because they're both orange. And now I have to use one pair that I have information for both of the triangles. I could use the red because I've already calculated the other. I found that B is 7.5. But a good practice is to use the original information just in case you end up rounding. So once again, I'm looking at the purple pair. If C is up top, that means this triangle is at the top. And so that means A goes at the top, Y goes at the bottom. Now let's sub in the info we have. Okay, if A is 4, is that right? Did I make that up? No. If A is 6, Y is 4, W I don't know, and C is 9. And that's the beauty of the T method. It doesn't matter where the unknown is. I multiply the diagonal numbers. 9 times 4 divided by 6. W is 9 times 4 divided by 6. I've got 54 divided by 6. Nope, I got 36 divided by 6, and that's 6 centimeters. And then I might say, okay, therefore, I found that B is 7.5 centimeters and W is 6 centimeters. Okay, and this PDF is, again, on Google Classroom. So if you had anything shorter than this, you are not getting full marks, right? This is how you show your work, including a statement at the start saying, hey, we've got similar triangles. So this is why I can do this ratio situation. Okay, let's look at question 3. Any questions about that? All right. Question 3. Okay, it's an area question. Great. So I've got 2 similar triangles. How do I know they're similar? Well, I see all the angles are the same. So first thing I'm going to do is I'm going to write my statement. Part of the reason why I write the statement is because I want to make sure I know which angles go together. So for the first triangle, I've got PRQ. Okay, so now let's do the work. What angle is corresponding to P? S. What corresponds to R? U. What corresponds to Q? T. This way, I know which ones go together. I'm asked to find the area. I know the area of STU. All right, so I'm going to say area of triangle PRQ or QR, whatever. We can change the order if we're talking about area. Over area, of triangle STU equals, now we need to find one side that corresponds. So I've got PQ, ST. Those are corresponding. So I've got ST and I've got PQ. Questions? I'm not done because I know to find the area, I have to use the ratio of the squared ratio. So I know that STU is 72. I'm looking for the area, and I've got 12 over 9 all squared. Now, if you want to use the T method, or generally when you have a fraction that's squared, you're going to square the numerator and square the denominator. Right? And then you'll use the T method to solve for the area. Please.
So in other cases, like for our last unit, when we were doing quadratics, we would do the 12 divided by 9 squared. Why in this case do we...
Like you would do it in a decimal?
Yeah.
So so first of all, I hesitate to use any decimals just in case you end up rounding.
Okay.
However, you can do it into a decimal. That's going to be 1.1. Oh, no. Because 12 divided by... Yeah, so no. If you ended up getting like a whole number, then you just have a different way of manipulating the equation. It's fine, but just watch for the decimals. All right, I won't solve because I was setting it up. Next, we've got question 5. Let's see if that's different. Okay, so for question 5, we've got a word problem. Luckily, they give us a nice picture. Okay, and okay, so we want to know how tall the building is. Okay, we've got 2 triangles. This is like a method of actually figuring out, you can use trigonometry to actually figure out the height of something really tall. If you have something shorter, right, you're like, I know this is 5 meters tall, and it casts a shadow of 4 meters, and this big building casts a shadow of 30. Well, it's similar triangles because the sun is so far away that these lines cast by the shadow are parallel. And so that means that this angle here is corresponding, and this angle is corresponding, and this is a 90-degree angle because we hope that our buildings and our flagpoles are perpendicular to the ground. So we can make these assumptions, and then it's like, oh, we've got 2 similar triangles. How do I move forward? I would give my triangles names, like letters like A, B, C, D, E, F, so that then I can say, since triangle blah, blah, blah is similar to triangle blah, blah, blah. Then I set up a ratio. Then I solve. So all of that is necessary, right? Since statement, ratio, solve, and then statement. Right? So if you're not doing all those pieces, your solutions are incomplete. Moving on to 6. Okay, so question 6, again, word problem. Only trick here is that these triangles are not lined up. So it's a bit tricky to know which ones are similar. But let's use the good old OAT. OAT stands for opposite angle theorem. So when you have 2 straight lines that cross over, you can say that those 2 angles are identical. We are told from the diagram that this is a right angle and this is a right angle. And so based on a process of elimination, the other 2 angles must be identical. because all angles in a triangle equal to 180 degrees. So let's just give some letters. A, B, this middle vertex is C, D, and F. And all I want to do right now to set you up is to do the since statement. Since. Now, if anyone's tired of writing the word since, I love this. An upside down therefore, those 3 dots, upside down, actually means since. Isn't that nice? So I'll just write, moving forward, I'll just be writing since without the word. Okay? So triangle ABC is similar. Okay, so in your head, I want you to line up C, F, and D. What's the order? Okay, say it in your head. What corresponds to A, B, and C? FDC. Is that what we got? Okay. And now all we do is we set up a ratio, solve it, and give a statement. So figuring out the picture is key. And then it's like, oh, it's just a regular question. I know I'm not solving all of these, so if you want me to solve some of them, see me later. Okay, I'm happy to do that one-on-one. Yeah.
For this one, when you're solving, like, I know how to do it. It's just like you have to solve for C, but that's like 2.
Oh, I didn't even read what you're supposed to solve for. Goodness gracious.
When you're solving for C, can you say like you're wanting like decide like how to describe it?
What do you mean you're solving for C? Calculate the length of AB.
Yeah. Can you use
Oh, yeah. So good call. So is it more, how do we name it?
yeah, can you write it as
Yeah. So this is a good question. If I were to say, hey, this is side A, this is side B, this is side C, the problem is that in the lower triangle, this also is C. And it's like, well, there's no way that C equals C. I can't put the same variable on 2 different sides. So in this case, instead of using lowercase letters, what you can do is you can name these sides the 2 vertices. So let me actually set up the ratio with you. So we know this is 208. We know this is 24. And this is 30. So I want to find AB. So I'm going to say, okay, looking for AB. I have 208. I'm going to call that BC or CB. Sometimes you may have seen a little line on top of the 2 letters. You can do that. That's another way to show that we're talking about a line segment. So either a line on top or just saying between A and B, that's a line. Okay, now if we go to the smaller triangle, what corresponds to AB? Let's get the proper order. From A to B, okay, we're going to have FD. From B to C, we're going to have DC. Does that answer your question?
Yes.
Great, thank you. Okay, thanks for asking clarification. Moving on to question 7. Okay, we got the communication. All right, if you didn't do this, listen up. Malik thinks that 2 triangles on a page look similar. Describe 2 different methods he could use to find out if the triangles are similar. Explain your reasoning. So what's one method? Yeah,
You could check to see if all the internal angles are the same.
right. Use a protractor, check if angles are the same. Because, now you need to give reasoning or justification. Because in a similar triangles, all the angles, each angle has a corresponding angle, right? The 3 angles are identical in the 2 triangles. Okay, another way, but I don't have a protractor, Miss Sly. I only have a ruler. What could I measure? What do you think, Cruz?
The length of the side.
You got it. Measure all the lengths find the ratios, C is the ratio between each side identical. That's another characteristic of similar triangles. That one side divided by the other side will always give you the same number. Okay, that's question 7. Question, not 8, question 10. Communication. In triangle ABC and DEF are similar. The ratio of their corresponding sides is 3 to 5. What is the ratio of their perimeter? So when we talk about 3 to 5, what we mean is A, B, C similar to D, E, F. So if the ratio is 3 to 5, what that means is if you have on this triangle, if one side is 3, the other side on the corresponding side will be 5 long. If this side is 6, what will this corresponding side be? Okay. So that's just the ratio between the two. Now, when we found the area, we found we had to take that ratio and square it. Do we do the same for perimeter? Okay, discuss with the person next to you. Is it the same ratio or do I have to square it? All right, is the ratio the same or do we square it? Why is it the same?
Because all the lines are in direction. They're like part of like the ratios like describing all the lines.
Okay. How about this, folks? When I find the area, what do I do with two sides? What's the operation? Base, height, what's between them? Times. One side times another side. When I find a perimeter, what do I do with the sides? I add them. So I'm not multiplying them. So because I'm adding them, the ratio remains the same. And you could even show an example. For example, if I take these two sides and add them up, okay, on the smaller triangle, I'm going to have 9. Like if I go 3 plus 6, okay, what's the ratio compared to the big one? We're going to have 5 plus 10. Well, that's 9 to 15. And if I reduce that ratio, divide it by 3, I get 3 to 5. So you can just keep adding and adding more sides, but they all have the same ratio. So as you simplify that ratio, it remains. All right. And question 11. Okay, listen up. Are all isosceles triangles similar? Folks, what is an isosceles triangle? What's the characteristic? Two sides are the same length and two angles are identical. Okay, now are all of them similar? No, right? Because not all isosceles triangles are identical. How about equilateral triangles? Are all equilateral triangles similar? Yeah, because what are the angles of every angle? 60, 60, 60, 60. But isosceles, you can have and so if you're trying to answer this question, you're saying, no, it's not the same, not every time. Here's an example. Here's one triangle where that angle is 100 and these two are 40. Here's another triangle where this is 70 70, and this is 40. So although these two triangles are isosceles, they are not similar because they do not have the same angles. Okay.